Welcome, guys. In this presentation, we are going to derive the formula for finding error in quotient of two quantities, x and y. My name is Vincent. I teach mathematics at University of Nairobi. So let's go into the derivation process. So this is how we start. So let x and y be exact or true values, true quantities. Let by x and by y the approximate values of x and y. So error in x will be given by x minus approximate value of x. Let's call this one equation 1. And then error in y will be given by y minus approximate value of y. All this one equation 2. So then from 1 and 2 we have approximate value of x is x minus error in x. Approximate value of y is y minus error in y. So call this one 3, call this one 4. So the next we divide 3 and 4, i.e. by x divided by y is x minus error in x over y minus error in y. And then we can write this one as by x over by y equals to x minus error in x divided by y into 1 minus error in y over y. And then this can be written as x minus error in x divided by y multiplied by 1 over 1 minus error in y over y. Let's just play with this expression here. So this will be by x over by y equals to x over y. So I divide each of these two terms by y minus error in x over y. And then this is the same thing as 1 minus error in y over y raised power negative 1. So remember, this is the same thing I just saying. This is raised power positive 1. So when it goes up, then it becomes negative. Now, remember the binomial theorem. So binomial theorem states that, so this 1 plus h raised power n is 1 plus h, and then nh plus n into n minus 1 over 2 factorial h squared plus n into n minus 1 n minus 2 over 3 factorial h power 3 plus n into n minus 1 n minus 2 n minus 3 over 4 factorial h power 4 plus other terms. Or another version of the same binomial theorem is 1 minus h raised power minus n is 1 plus nh plus n into n plus 1 over 2 factorial h squared plus n into n plus 1 n plus 2 over 3 factorial h power 3 plus other several terms. Or another expression is 1 minus h. So when n is 1, so we'll have 1 plus h plus h squared plus h power 3 plus h power 4 plus h power 5 plus h power 6 plus other several terms. And in all these three cases applies whenever absolute value of h is less than 1. So let's call this one equation 5. So therefore we say equation 5 becomes applying binomial theorem to 1 minus error in y over y raised power minus 1 in 5. We have, so remember, this will actually conform to the definition of binomial theorem because error in y is a very small quantity. So over y, then we expect that quotient to be less than 1. So we'll have bar x over bar y equals to x over y minus error in x over y. So in this, at this point here, so this part here takes the role of h in this case. So using this third version, we'll have 1 plus error in x over y plus error in x squared over y squared plus error in x, error in y, not error in x, error in y over y cubed, this power 3 plus error in y power 4 over y power 4 plus other terms. So I'm simply applying the third case of binomial theorem to this term here. So IE will have bar x bar y equals to, so x over y into 1 plus error in y over y plus error in y squared over y squared plus error in y cubed over y cubed plus other terms minus error in x over y into 1 plus error in y over y plus error in y squared over y squared plus other terms of the same kind. So I'm just opening the brackets here. So the next step will be now opening the bracket. So I have bar x over bar y equals to x over y plus x error in y over y squared plus x error in y squared over y power 3 plus x error in y cubed over y power 4 plus other terms, and then minus error in x over y minus error in x, error in y over y squared minus error in x, error in y squared over y power 3 minus other several terms of this same, taking this multiplied by every term here. So to first order approximation, then all the higher order terms in x times y, error in x, so error in y squared, error in x times error in y power 3, etc., approaches to 0. So therefore, in this expression here, so this term will be 0, this will be 0, also everything that remaining here is 0. This also go to 0, this will be 0, and everything that comes after this term will be 0. So we'll have by x over by y equals to, here we have x over y plus x error in y over y squared, and then here we have minus error in x over y. So this, we can write this one as by x over by y equals to x over y minus error in x over y minus x error in y over y squared. So that we can say x over y minus by x over by minus by y equals 2 error in x over y minus x error in y over y squared. So this is just the error in quotient x over, because this is the true value, this is the approximate value. So error in the quotient x over y. So we can put under 1 LCM, we have y squared, and then so we'll have y error in x minus x error in y. So this is the formula for error in x and y, error in the quotient of x and y. Now, relative error in the quotient x over y is error in the quotient over the true quotient, which will be y error in x minus x error in y divided by y squared, and then you divide this one by x over y. So which will give us relative error in the quotient x over y equals to y error in x minus x error in y over y squared times the reciprocal of this is y over x. So y1 goes with this. So that relative error in x over y equals to y error in x minus x error in y. So y times x is xy. This can be written as y error in x over xy minus x error in y over xy. And then here y and y crosses, x and x cancels out, so that relative error in quotient x and y is error in x over x minus error in y over y. So this is a statement for the relative error in the quotient. And so if we call this one star, then we can say star is the error, relative error in quotient x over y. So you see that this, the same thing as saying relative error in the quotient x over y equals to, so this defines the relative error in x, this one defines the relative error in y. So this one we can say relative error in quotient x over y can be expressed as a difference of the relative error in x and y. This can easily be seen from this one here. Or now to define the relative error in x and y as given in the box, error in x over x minus error in y over y, then it tells you that this is the same thing as saying this is a value the same as is less than or equals to absolute value of error in x over x plus absolute value of error in y over y. So thus, relative error in a quotient of two approximate numbers is less than or equal to the sum of the relative errors of the numbers. The maximum value of the error in x over x minus error in y over y is absolute value of error in x over x plus absolute value of error in y over y itself. So that is how we define the error and relative error in the quotient of two quantities, x and y. So feel free to ask any question using the email given or any other platform where you can see my contact, which is given on the cover page, and you can always subscribe to my channel. So thank you.